Welcome everyone to this very special edition of Prairie Skies. This is not the regular fall Prairie Skies, so there's going to be a little bit of rambling, but the big thing is, well, Mars. Oh, it's been so gorgeous in the sky lately. It's been phenomenal. So we're definitely going to get to that. Now I'm going to just move some things around so I can start sharing the screen. Uh, there we go. Okay, so I am in the planetarium right now, which is the background you can see all around me, all these sad empty chairs. Wish you all could be here with us. Now, when we have our programs here in the planetarium, we're looking up at the dome-shaped ceiling, but what you see in my screen share is what we're actually looking at when we're looking at that ceiling. But instead of looking at it on a flat screen like we're doing right now, well, it's sort of like on the inside of a giant bowl that's turned up over our heads. So we're going to be doing a lot of pretending with this. So this is our sky earlier this evening, except not the real sky. The real sky tonight, too many clouds. Oh, so many clouds. I looked at the sky last night and it was really pretty. Got to see Mars, got to see the moon and some stars. But of course tonight, all those clouds. But that's okay. We're not going to have clouds in our planetarium time. Now I am going to change the view a little bit here. Ah, there we go. I know, it made it look like a giant egg, right? Well, that's going to let us focus on parts of the sky a little bit better. And I'm going to go ahead and let's see. I'm going to put up our direction letters. I know we normally don't do that early on in a Prairie Skies, but that's all right. This is a special edition Prairie Skies. And we're going to turn this around to face the direction west. So this was just before sunset. And we're going to zoom in our field of view. There we go, zooming in even more. And now we see big W4 west and the sun getting ready to set. So we're going to go ahead and do a fast forward on that sunset. And we'll set it for, oh, pretty close to the time now. Not exact, but pretty close. And I'm going to do a little bit of magic to make it look a little bit more real. Some settings that I worked out earlier. Gonna let it run, and now I'll back that view away. Okay, so I'm gonna back the view away even more. All right, so it's a lot more colorful than I had originally planned it to be. So I'm gonna tone down the color on those stars. Okay, so now I'm gonna have us face the direction north. We're not gonna spend too much time on it, but here we go. And now we can zoom in a little bit more. Now, see, I would not be able to do this very quickly in the planetarium if we were here together, because we would all be we would all be getting, there's my sky, we would all be getting dizzy moving it around that fast. Now, the view here is facing north because I wanted to show you that that neat trick for finding the direction north. And what we do is we use the group of stars down here in the well, it's in the northwest this time of year in the evening, and it is the very famous Big Dipper. And something that Gautam said in that last program about looking at the cover of that book with the picture of the Andromeda Galaxy and just staring at it for hours, well, it reminded me of how I had a similar experience, but it was with diagrams of the Big Dipper, how it is in our modern times, how it was hundreds of thousands of years in the past and how it would be hundreds of thousands of years in the future. And it was staring at that and trying to get my head around how all these stars in space must be moving around. That is what got me interested in astronomy in the first place, because where I grew up, we had too many city lights and things, so I really couldn't see much of the sky. So it was that kind of experience. So let me go ahead and put on the, I'm going to use the annotation feature, use the lines, and I'm just going to connect the stars of the Big Dipper. Now, in town, most of the time, the stars stand out pretty well in the Big Dipper, and you don't see all those other faint stars that are all around. But if you're out in really good clear skies, super far away from any city lights, the only times I've been around skies that clear, I've had a hard time finding familiar patterns like this Big Dipper, because I was so accustomed to the light polluted skies. But our pretend sky here on our screen does not have the light pollution. So we're going to go ahead and do a trick now that you've probably seen in the planetarium here with me. We are going to use that Big Dipper, the two stars, not the handle stars, but the ones farthest from the handle, and we're going to draw an imaginary line, kind of like what I just did using the annotation feature, but I like to use the shortcut because it draws the line and then makes that lovely circle. That star is the North Star, real name Polaris, meaning pole star. And if we were at the North Pole, that star would always be straight overhead at the tippy top middle of the sky. Now here in our screen view, the tippy top middle of the sky, it's going to be in different places on the screen depending on which view that we're using. So if I back it out a little bit, then I can use a dot that we made for here in the planetarium to mark off that overhead point. We call it the zenith. Do you see that big weird looking green dot there? Yeah, let me zoom it out even further, and then you can see in that full view that, yeah, that dot is smack dab in the middle. All right, I'm going to stay in this view. I'm going to take that dot away, and we're going to turn all the way around. This is going to go fast. We're going to turn all the way back around there to face south. I know, I would not move it that fast in the real planetarium, not at all, that's for sure. We would all be getting way too dizzy for it. But I do want to show a few more things before I get onto those planets, including Mars. Yes, I promise Mars is what we're going to talk mostly about. But I wanted to point out that it's fall, right? It's autumn. And oh, autumn is, in my opinion, the best time for seeing what we call the summer triangle. Summer triangle, well, it's made from these three stars. And I can go ahead and draw it out on the screen. The stars are called, we'll start with, there we go. We'll start with Vega, go to Deneb, then go to Altair, then back to Vega. So we call it the summer triangle, but autumn's the best time to see it because I don't have to stay up so late and it's not so hot and muggy, not as many mosquitoes. So definitely some advantages there for me. And I'll see if we can keep it in view if I zoom in a little bit, and then I'm going to tilt our view up. Ah, there we go. Now we can see it. And you can see the hazy band of light going through it. It looks like a cloudy smudge all across. And that is the light from the stars in our own galaxy, the Milky Way. And that's the area where it's thickest with stars. And we're looking at it edge on from the inside out. So let's go ahead and just real quick check out some things with that summer triangle. The stars themselves, Vega is part of Lyra the harp, musical instrument there. Deneb is part of Cygnus the swan. Looks like a big old goose, I know. And Altair part of Aquila the eagle. I always have a lot of fun with those, but we can imagine anything we want out of those stars. We sure can. Like maybe the stars of Cygnus instead of a swan or a goose, maybe it's an airplane. And of course, the favorite for people here at Starkle for many years has been, yep, the summer triangle pizza, or perhaps some dessert. We do have pie in the sky. And we have some recent additions. I have finally, as I've been promising to fifth graders for years, I have finally added a nacho chip. So when we are able to be here together in the planetarium again for regular public programs, we will finally have the nacho chip in the sky that fifth graders have been asking for. And I added something else. Now, my sister was not able to join us for this this program this evening, but the last time she saw me do a program, she said, "You know, my dog's face is shaped like a triangle." And so that is Bo right there. And just a adorable, sweet dog. We call him Puppy Man. And I've been able to visit a few times in the last few months and was able to, able to see Puppy Man Bo. But here in the planetarium, he'll be larger than life up there on the ceiling. So looking forward to that. All right, a couple more things now. I'm going to turn the view back down, lower toward the horizon, and setting off to the side, right over here. My favorite star, Antares. Now, Antares, oh, yes, it's definitely more of a summertime star. It's not easily seen in the fall. I mean, it's setting right after the sunset, so it's just not something that we're going to see very easily. But if you're able to spot it, you're like, wow, yeah, that's kind of red. And since it's low in the sky, it's gonna be like flickering all over because it's just you're looking through way too much atmosphere when you're looking at it low on the horizon like that. But, oh my goodness, Antares, let me get its name tag up there. We'll see if it shows up. It might not be, yeah, the name tag might not show up because of how low it is, but the name, oh good, there it is. We just barely see it. I'm gonna turn the view around just a little bit. We're gonna face it here. The name Antares means not Mars. Not Mars. And it really does look a lot like Mars, especially when you see it higher in the sky when it's not flickering, twinkling quite so much. But Antares, not Mars, does look a lot like Mars. So if you see that star in the sky next summer and you're like, wait, is that Mars? Like, no, it's not Mars, but people have thought it looked like Mars for thousands of years. Now, Mars is not in that part of the sky, but it is above the horizon, and we're going to turn to look to it here very soon. But there's two more planets that are in our field of view right now as we look toward the south, a little bit southwest there. And I'm going to put us back due west, I'm sorry, due south. And those two planets, well, we've got the biggest, so I'll zoom that up for us. Ooh, look, the great red spot is just coming into view. Wow. Beautiful, all the swirling clouds. Oh, marvelous. The other that's next to it is the second biggest. I can make it bigger. Jupiter will be in the way, but it'll be worth it. Here we go. Love those rings. I know. Don't they look like we could just go running around and around and around on them? Nope, they are not solid. They're just seemingly countless numbers of pieces of ice and rock and dust just all going around together. Just incredible. And through a telescope, it kind of looks like that. It looks like a little Saturn when you look at it through a telescope. So it's kind of neat, like, oh, we've got these planets together. Well, there's a region of the sky called the ecliptic, And that is where we always find the the sun, the moon, and the planets on or near that line. Now, to make the sky look pretty, I have an actual photograph of the real sky behind the planets. So to show you this line, I'm going to gonna have to do a little bit of trickery. See if I can get it on top of everything. Nope, then I will cheat because I have the technology. It's my behind the scene job. So if I take that down, there's the ecliptic line. It's marked off in months and days, so kind of like a calendar, which kind of is what it is, because it's where the sun is at different times through the year. So it's marked off for the position of the sun, but it matches with the plane of our solar system. Like the solar system is pretty much flat like a pancake as far as the planets go. So we do always see them together in that region of the sky. All right, go ahead and put that pretty, more realistic sky up there. And I'm going to zoom out the view because, well, we do want to look at Mars. No, I'm not going to zoom it out. Wait a minute. I set up this really cool way to be able to view it on the screen. So there we go. And I'm going to zoom in and maybe zoom in a little more. All right. So that'll be okay, I think. Oh, yeah, I would cheat to zoom in more, but I don't necessarily need to do that. So Mars tonight, you know, way beyond all those clouds that are covering us here on the Earth, Mars tonight is near the moon. Now, the moon was full yesterday. It's not full now, but it's still almost full. I mean, it's just past full. So they would be a really nice sight without the clouds in the way. Now, on the screen, Mars looks a lot bigger than it would in the real sky. We do that to make it appear more bright, because in the real sky, it's a lot brighter than it usually is. And that's because right now, Mars is at its closest to us. That's the season that we're in, right? Every 2 years and 2 months, Earth and Mars get to be close again because Earth goes around the sun faster than Mars. Mars goes around the sun. Earth catches up, we catch up, we catch up, and we caught up. So now we are at our closest, and from the coming weeks and months, we're going to be leaving it in the dust. Well, not really in the dust because we're just going through space, but yeah, and we're going to be continuing on around the sun on the Earth faster than Mars. So it's going to be getting fainter and fainter and fainter as we pull away from it. But right now it is at its brightest, in its prime, looking really great. And so the next few nights, the next few weeks, even when we have nights that don't have all these clouds, check it out. It is spectacular, and it really is very orange. Not as red as it's showing up here on the screen, but very, very orange. Now, sometimes I get this email saying Mars is going to be as big as a full moon. Well, that doesn't happen. No, that came from a really old newspaper article where somebody said that through their telescope it would look big. But yeah, it's not going to look that big. Although here in the planetarium, we can do some fakery, and I could make it even bigger than the moon. Hey, you know what? That makes me think of something. Why don't, why don't I freeze this view? I'm going to bookmark this view. And then I'm going to, I don't know how well this is going to work. I mean, it worked when I tested it in recording, but we're gonna try it. So I'm gonna fade all of this out and going to load up a this is a script in the Planetarium software that's actually using the Planetarium software, and it was made by some friends at a planetarium in Poland. And what it does is we fly to Mars, and they've got real imagery that gets put on top of it, which kind of, yeah, let me make that zoom out a bit, which you'll see it'll look kind of weird, jaggedy at times. So we're flying to Mars, And as we get closer there, you see how it's jaggedy. That's where the pieces of the actual images are coming together. But as we get closer and fade out to even more close-up images, that will part. So in July, right, there was a spacecraft launched carrying another rover to Mars. It's another mission to Mars. Oh, look, that's a terrain map, right, showing the heights of the mountains and the depths of the craters. And that is the crater where this spacecraft, where it's going to be dropping off its package, right? So the the main craft is Perseverance, so that's what's going to be there, landing on Mars, studying a bunch of stuff, and kind of like Mars Curiosity did in landing. Although I read that this mission has a lot more cameras, so right now we are seeing what we think it would look like as the spacecraft is entering the Martian atmosphere and landing, but they've got extra cameras on it to be able to get better footage of it for this landing. And now we get close up of more terrain, and we see that once this rover gets set up, right? Once Perseverance gets set up, it's not on its own, but it has a helicopter. It has a helicopter. It's called Ingenuity, and they're going to be able to use it to do different measurements, but also to scout out other areas nearby for the rover to check out. So I don't know how well this is coming through. I do hope that when we can open again to the public, that you'll join me here to see this larger than life up on the planetarium ceiling. And I'm going to see if I can program this model then to fly over our heads. I think that would be kind of fun to be able to do. But it's going to be doing all this exploration. Now, when is the landing going to happen? That is in February, and I had to write it down because I keep confusing the date with other dates. So I want to say it's February 18th. Yes, February 18th, and it's supposed to be at 2:30 in the afternoon our time. So we wanted to stay up middle of the night to see it, although that was kind of cool for a lot of folks. But 2:30 in the afternoon is when the landing. They'll have it on NASA TV. If we're here, we'll be able to, and in person, we'll be able to get together here for it. Just so excited about this mission, and I mean the helicopter. It's a new step. It really is. So it's a prototype of what many missions are going to have going forward to learn more about Mars, and maybe someday. And the maybe used to be a really big maybe, but now it's becoming more and more likely that at some point we will finally be able to have people go and visit Mars. And just think, those first human visitors to Mars are probably already born, probably already, I mean, maybe in high school, maybe in elementary school, maybe in college. So yeah, look around the folks that you know and think, oh, you know what? I know somebody that will end up going to Mars. Now, me, I don't know. When I was little, I was like, hey, I want to go to Mars. And then I got a little older. I was like, oh, well, maybe I can just send my sister to Mars. No, just kidding. Although, she would do really well as an astronaut on Mars. But now I'm like, yeah, I'm just going to encourage other people to go check out Mars. So I'm going to bring back our view of the sky that we had it set up for before, although now we've got the larger view and it's facing south. So we'll get that coming on here. Only I'm going to do something, I don't know if this is going to work. This I have not done in front of a live virtual audience, but I'm going to start manually setting the date for February 18th. Okay, so this is the night of February 18th. You'll notice we have the familiar winter constellation, Orion. The 3 stars in a row make his belt. He's got shoulders and legs. And if we follow the belt stars up in this direction, we get to the bright star Aldebaran with that V-shaped cluster. And we keep going, we get to the Pleiades. Beautiful, beautiful Pleiades. Let me zoom in just a little bit more, and then I'll do the the height change, because on that date, look at what we have. We have Mars and the moon, not just past full like it is tonight, but still, it's going to be kind of neat that we're going to get to see that night Mars in the night sky. And I do remember this is where I get to feel really, really old, right? Way back in 1994. No, really, it was July 1994, and it was 4th of July, and the Mars Pathfinder mission that they had landed. It was successful. We didn't have internet as widespread as we do now, so it took a long time to download the very first picture saying that yes, they made it. And that night, of course, 4th of July, everybody's outside looking at fireworks. Everybody's looking that way at the fireworks. Me, I'm looking that way up at Mars, because it was just such a neat thing to think of all the exploration that was going on, and all the exploration that was to come. And here we are all these years later, and it is really happening. I want to show just a couple of things here. I've got I've got a web browser that I'm going to pull over into here. I want to show if I can get it to overlap. There we go. Okay, so the Mars 2020 is what the mission was originally called. It's now Perseverance rover. Their website has this wonderful countdown at the bottom for when it's going to land and how far it is from the Earth, how far it is to Mars. So right now it's still closer to Earth than it is to Mars, but you know, the numbers are changing. Shows the speed. I mean, look at that. 65,385 miles per hour. That's like 10,000 times what we usually drive out on the highway, right? So that's pretty fast out there in space. I mean, it's not the fastest spacecraft out there, but certainly way faster than anything we deal with here in our own travels on Earth. So that was one I wanted to show, and some other pages to show. I'm going to have to, my Zoom controls are in the way, so I'm just going to close that out. There we go. And I'm going to move it back over. I'm just going to take one at a time, I think. That's going to work. Yes. Ha. Okay, so one of those Mars missions was the reconnaissance orbiter, still going strong around Mars. It really is. And it's got this amazing camera, incredible camera, and it's nicknamed High Rise. And let's see if I could have to look over here to see where it is. Yes, the High Resolution Imaging Science Experiment. I don't know why I can't memorize that. I don't know, but the gallery of their images. This is something. Careful, my friends. This is something you want to look at only if you have a lot of time, or you set a timer for when you need to do something else, because it is an amazing rabbit hole of different kinds of images, incredibly detailed images of different Mars features. And if that sounds kind of fun, you can also check out, this is part of the, if you've ever heard of Zooniverse, this is a part of it. It's called Planet 4, Mars being Planet 4. And what they do is they show images from the HiRISE camera, and you get to help classify the features. Now, these features have been identified vaguely through, I mean, AI is getting better for sure, but you get people set up an account, log in here, just do it by hand, analyze these different pictures, and they tell you the different kinds of features to look for, show you examples, and then you get tools to actually measure the different features, and you can then submit it, and then researchers will take closer look at these things after they've been more fully classified and marked with greater details. So it's citizen science. So you can participate in this. It is a lot of fun, and the images are just incredible. They really, really are. So also the high-rise camera does have its own, they have a website there because it was made from the University of Arizona. So if you want to learn more about that camera setup and the kinds of data that are produced from it, because there's like with remote sensing, it really is what it is. You can get data that you can use for creating 3D models, very detailed 3D models. So if that's what you're into, there's lots to be done there. So much fun, it really is. And I do want to point out that, you know, in our at home that we've done from home, our Prairie Skies that we've done from home using open source software, we've been using the software Stellarium a lot, which you can download, but you can also check out the, if you don't have a Planetarium software system like what we have here, or you don't want to install that software, they do have Stellarium Web, which doesn't have all the features of the main Stellarium, but it works really nicely for making simple star maps and just checking out, hey, what planet do we see up there? You know, you can use the app on your phone, but then you can also come inside and check out more detail and find the constellations, constellation pictures, lots of different things that you can do. So I did want to point that out to you as well. All right, I'm going to start closing off here, and I'm going to stop the share on the screen. And I don't know how many folks we still have with us. I do want to thank you for joining me here. And let's find out how many questions. What questions do we have? I think, Eric, you've been answering quite a few. I couldn't see the chat. It was behind the Digistar window, so I wasn't able to see that.
I was just making fun comments. That's what I could say there. But folks, yeah, remember, as we did before, just feel free to raise your hand and we'll be happy to unmute you so that you can ask your questions, okay?
Or I could show more constellations because the emphasis of this really was Mars. Mars, 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 Mars. No, I really do say that to myself. Seriously. Eric is shaking his head because he hears me in the back studio room where I work, and he'll just start hearing me chant that, you know?
I saw you Mars yesterday and the day before. It was quite bright coming up in the east. So yeah, easy to catch. So if you're looking and you see a real bright light in the east with a little bit of a reddish tinge, that's the red planet.
All right, somebody have a hand raise? I see somebody said hand raise.
Oh, somebody asked if this, oh, there we go. Peter Muller has, or Mueller, sorry about that. Let me go ahead and find Peter in here and I will unmute Peter to allow them to ask their question. Okay.
Muted?
We just barely heard you just now. Go ahead and try to speak.
Hello? 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 You can't hear me?
We can hear you. Just speak up a little bit.
Who are we talking about going to Mars? SpaceX or NASA or what?
Oh, as in what company, what organization will be taking people to Mars? Or are we talking about the robotic missions?
Right now. Are we talking about the robotic mission? Yeah, when was that? When is that getting to Mars again? I know you're talking about it.
Oh, February 18th.
February 18th.
2:30 p.m. Central Time.
And so this is the Mars mission that's specialized. And it's going to look for organic signatures of things and all that. Yeah.
Yeah, a lot of very similar instruments to what was on the Curiosity mission. So it'll be a lot of those. But there's the new stuff, like the helicopter. Woo! Yeah.
How?
Peter, we're having a real hard time hearing you. If you could speak up somehow.
You know anything about the helicopter? Is it electric? I mean, it must be electric.
Yeah. Waylena, what is the power source on it? Is it entirely solar powered, or is there a...
And how do you have a helicopter on a planet with almost no atmosphere?
Excellent question. they've been doing extensive tests to make sure that even under that low atmospheric pressure, that it can still achieve the lift. A major component of that is making sure it's as light as possible. But they were doing tests under similar atmospheric conditions here on Earth, and it was successful at achieving that lift.
Yeah, and that's why this is the prototype of the future going forward. So don't know how well it's going to work. I mean, they've put a lot of serious research into it. I mean, think about it, we know a lot about the Martian atmosphere and the conditions there from all of the previous studies, but this will be a chance to work out a lot of the bugs on what it would take to be able to maintain that type of flight vehicle through the thin Martian atmosphere.
Is it
That's also why it's not the greatest model for exploring other places in the solar system.
I mean, is it solar powered itself? I mean, does it have like a charging station on the main lander?
That's a really good question. Yeah, I'm trying to bring back that page that I closed on the. I know. Why did I
mentions in the chat.
Okay, 350 watts.
Jeff mentioned in the chat that the batteries generate about 350 watts. I assume that means that maybe the solar panels on Perseverance will probably help keep it charged, because you probably need your panels what the helicopter can carry in order to maintain that.
Yeah, I wonder if it is a charging port similar to what we now have, the easier charging that we have for phones and other devices.
Hopefully it's at least USB-C. little sarcasm there. All right.
Don't really have any specifications on the helicopter though.
Well, there was one just shared in the chat. Jeff decided to share part of the Wikipedia article to it.
And I just found the page linking from the mission page that I shared earlier. So they do have a page that is dedicated to the helicopter, and they set it up before they gave it the name Ingenuity. It's got a lot of there's a lot of information on it, the science goals, and some of the technology.
Yeah. Derek asked also if this is going to be recorded and put on our YouTube channel. We are recording it, yes, and the hope is that these shows, as a record of them, we'll just throw them up on YouTube for anybody's enjoyment.
Right, because this is going to be one long recording of both sessions. I'll probably take it and split it into the two.
I actually hit stop recording right after the end of the one show, and then
okay.
Again, so it might have already been split, so you don't have to.
Okay, so if it's split, that makes it a lot easier right off the bat.
Yeah. Folks, if you have any other questions, feel free to raise your hands.
Do you think they're going to send old people to Mars or young people?
Well, that depends on who goes there first.
That's true.
Again, if you ask a lot of young people how old is the old people, get a very different answer. And if you ask me what age would be old people.
Right, the first people on the moon were around 40 years old at the time, right? So there was that, and do you define them as old or young? That's a good question.
Yeah, I just turned 50 a couple weeks ago, so you might not want to answer that question.
Mm-hmm. It's all relative. We've already learned that in physics a long time ago.
Well, I mean, the people they send to Mars, it's not going to be a two-way trip. They'd be staying there. They'd be staying on Mars, right?
I've heard that speculation about people staying on Mars for the rest of their natural lives. So yeah, that's a possibility, but it all depends on what they design. I mean, you've seen enough fictional accounts where people would have a temporary mission on the planet and then come back to Earth. So it kind of depends on what the capabilities are and how much can be sustained there. I would think that they would want to make sure they can actually grow plants before they actually decide to make it a one-way trip.
Yeah, how you would need, I mean, you need radiation shielding to grow anything on the surface.
Absolutely.
I don't know, has there been any research into that, like finding a way to actually use natural sunlight, but have it shielded enough that it won't instantly kill everything?
Did you catch that, Waylena?
Oh, research about shielding it so that they can grow things
Gotta die.
without it killing it, everything.
Yeah.
I know there's research. I don't know of any of the of any conclusions on it. So I don't know if they've been successful in actually setting up some sort of greenhouse to make use of the light, or if they have to do something really hinky like, you know, use solar panels to charge up artificial lights inside of a shielded growing environment.
Yeah.
When it comes to spelling out the ideas, there's no limit to what ideas get put forth. So they're definitely working a lot of angles.
Yeah, and Jeff Bryant mentions in the chat there's water can be used for this. That's actually a plot point in the Netflix TV series Away about how water is being used as a radiation shield there. You can bet definitely that whatever knowledge we've gained from the ISS over the last 20 years is going to be applied to that. It might be safer to do a sort of a test drive of such a long-term mission on the moon first, because we can get there quicker to save them if something goes wrong. It has a fantastic question. She wanted to know what you studied in order to become a planetarium producer.
Oh, I studied everything I could get my brain around. I started. Well, I loved astronomy as a little kid, learned everything I could about it. And then in college, I started off majoring in physics, but my background really wasn't all that great. My grades were just terrible. But then I started working at the planetarium there at the University of Toledo where I started. And oh boy, it was like, you know, fish in water kind of thing. I just took to it very well. This was the old day where production technology was all the 35mm slides, these little, you know, see-through pieces of film that projector lights would shine through, and the pictures would go up onto the ceiling, and the old-fashioned star projectors, which we do still have one here. We call it Carl. He's sleeping
Yeah,
now.
you can kind of just turn the camera at the sort of stuff.
Yeah, but he's sleeping right now, so it's not.
Well,
He's
I'm also saying the
inside.
buttons too. The buttons
And
would operate the slide projectors, right? So
yeah,
yeah.
we had to be able to operate slide projectors, and of course point to everything. Now I already knew the sky when I started out, so I had to learn a little bit of public speaking, which is much easier in the dark than it is in front of a, you know, live room of people, or even here online. This is kind of intimidating compared to, you know, the comfort of being in the dark with, you know, just what, 120 of your, you know, closest friends here, as we would on most weekends. And I just learned everything I could, started to, you know, graduated, went on to, I ended up getting a degree in geography, learning about remote sensing, figuring, hey, the same stuff we use for satellites studying Earth is the same stuff we're using to study other planets. And so I, you know, worked that angle. And then I got a planetarium job in Cleveland area. And then for several years, I was at a planetarium in Nashville, Tennessee that did commercial productions for sale to other planetariums. And from there, I came here, and that was in the year 2000. And over the years, we went from the old-fashioned methods to the new digital methods. Fortunately, here at Parkland, I was able to take, you know, one semester at a time, take a class here, class there. So all kinds of computer programming and graphics classes, and just been able to put it all together. Along the way, I got really interested in open source software for production. So a lot of what I do, 3D software like Blender, and a whole bunch of different things. You know, don't get me started on open source production software. I even have a blog about it called FOSSDome that I started last year. And it's just so much fun. I really love it. And I've just been able to take any interest that I have and find a way to make use of it in this amazing environment. And I've met so many wonderful people through this job in my career, other planetariums that are out there. Been very active in professional organization for planetarium folks. This will be our first year not having an in-person conference, so that's going to be kind of sad. Here at this planetarium, when I first started in 2000, 2000. I came to an astronomy club meeting and met Jeff Bryant, who's been on here. He's my husband now. We got married in 2003, but we met here in the planetarium. One thing I can say for sure about this field is that if you're excited about it's not just astronomy anymore, but other types of science. But if you're excited about public outreach with science visualization, you can make a space for yourself. There's so many different aspects to it now. So it's a lot of fun, and you can end up doing it even after training officially for other things too. So I hope that answered the question and didn't put everyone to sleep.
All right, she seems very satisfied with your answer. Fantastic. Folks, did you have other questions for us?
Okay, well, if no other questions, the special edition Prairie Skies, for lack of another title, we just wanted to I want to do something to emphasize Mars, because Mars is at that closest point right now. So it's something cool where, you know, the next clear night, you know, check it out, look out there. We're going to have more of these. We might come up with a better title than Special Edition Prairie Skies, but we're going to have more of these after the Kaler lectures through this season. But we also do have the regular Fall Prairie Skies that's every other week. Eric, when's the next one? Is that next week?
It is next week. That's correct.
So next week at 7 will be the regular Fall Prairie Skies. And so we have that as well. And if you know any school teachers, we are starting up the virtual field trips now that we've got our regular programs, our regular live programs, I should say. The recorded ones, the ones that are like movies, those are so awesome, but they just don't translate as well to the flat screen, and it's just not really worth it to try and set up for that. It's better to wait and then have everybody come once we're allowed to do that, you know, once it's all safe and everything. But all the live programs were set up now for doing those field trips virtually. So if you have teacher friends, let them know. And definitely write to us with questions about things that you would like to see featured in future editions of this special edition Prairie Skies, whatever we're going to call it, whatever you want to call it. Just send us a line. You know, our email's online. There's also planetarium@parkland.edu. That email address goes to both of us, so we both get those emails. So thank you so much for joining us. Eric, anything else?
No, yeah, I mean, I love the idea of taking requests and doing just a night sky spotlight, you know, one that's better for light pollution. But, you know, focusing on a planet of choice, focusing on an upcoming event, like, you know, after a future one of these, we'll definitely have to talk about how Jupiter and Saturn are getting really, really close in the night sky. It's going to be amazing in December. We'll definitely have to focus on that after the December talk. So that'll be a lot of fun. So yeah, if there are no more comments, folks, I'm going to hit stop recording on this, and you're welcome to